So the first approach that we are going to look at is a brute force, in which basically we try and compare each element with every other element. So here I'm just going to consider the provided example in Leetcode. This is going to be my nums array, and IDX is nothing but index position in the array. In index 0, element 2 is present. In index 1, element 7 is present. Index 2, 11 is present, and so on. So basically all I need to do is try and compare every element with every other element in this manner. So when I say compare, I just try and add all these elements and see if they form the target. And next comparison is going to be compare element at index 1 with every element going forward. And the third comparison is going to be between 11 and 15. If you see, every element is being compared with everyone in a recursive fashion. So the runtime complexity of this one is going to be like big O of n square, and space is going to be big O of 1. We can quickly look at the implementation for brute force approach. So I would require a 2 for loop that traverses the elements from left to right and sum them up to see if it forms the target. So that's going to be like nums.length -1 up till the last second element, because j is gonna reach up to the last element. So I don't want to repeat the last element twice, and hence I is gonna go up to the last second element. J is gonna start from I plus 1 because we would have compared all the previous combinations, so we don't want to repeat that. That's going to be the J loop, and if my nums of I plus nums of J equal to target, meaning like I have found the elements which sum up to the provided target, I have found my solution, so I can just return the result. I need to return the indexes here, so this would be the right solution. But based on our current implementation, there is could be like it could exit out of the for loop, so we need to probably do a return statement if in case we did not find anything that adds up to the given target itself. Since no such index exists, I'm gonna return -1 here. Let's try and run this. It works fine. So it does give me the solution, but the runtime complexity is big O of n square and space complexity is big O of 1. In the next step, let's have a look at how we can optimize on top of this. The next solution that that we could optimize on top of the previous brute force approach is like thinking about a given problem. Here the problem is straightforwardly asking us sum of two numbers that adds up to a given target. But in the brute force approach, what we try to do is like try and compare every element with every other element. So what we probably wanted to achieve over here is something like this, where a plus b is equal to the target. So this is what we basically wanted. So target is 9 and a is going to be the current element that I am looking at the nums array. So basically I want to see have I seen b so far. So this could be transformed into in a mathematical expression. So given a current element, I would at any point of time can know what other element can be present to sum up to the given elements. So here I can use additional data structure, something like a hash map that keeps track of the elements I've seen so far and the index position. So say for example, I did see 2 so far. So what would be the other element that I can do, that is like target minus a, so which is 9 minus a. I'm actually looking for an element 7. Have I seen it so far? That's my question. And when I look at the element 7, which is index position 1, the question is, have I seen so far the 2? When it comes to 11, it's gonna be like 9 minus 11, that's gonna be minus 2, and when it's 15, it's gonna be like minus 6. So with this kind of map being constructed, at any point of time I can clearly say, have I seen 2 elements that adds up to the given target. So here the time complexity is gonna be big O of n square, and space complexity is gonna be big O of n. Sorry for this, it's going to be big O of n for the time complexity because I'm going to iterate the elements just once, and the space is big O of n purely because I'm storing this entire structure in a hash map. Now let's try and implement an optimized approach for the given problem. So here I would be requiring an data structure that stores me the given element in nums and its index position. So for that purpose I would be using map. The key and value of the map are integer. So I have created a hash map. So the next obvious thing is like to traverse the provided nums array from left to right. So I'm going to use a for loop. In this case, the first mathematical approach where b equal to target minus a, so we can call it as a complement. So that's gonna be target minus nums of I. Next thing is like, have I seen this complement in my map before? If I see this is the solution that I need to return. So I can just say map.getOff complement and return the index. If it's not, say for example it does come out of the for loop, I need to return an array which doesn't exist. So that's gonna be -1 comma -1. And also here, once this is done, I also need to update my map. I need to insert the elements I've seen so far. It's gonna be nums of I, comma I. Let's try and run this. Yep, it does work fine as expected, but based on the runtime optimization, we are running at a time complexity of big O of 1 and a space complexity of big O of n. The reason being I'm using additional data structure of map. Thank you.